everyone, this is the introduction video for the Modified Atwood Lab. So this is really going to be the next discovery lab that will bring us into the second part of our forces unit, where we take those free body diagrams and figure out how we can interweave kinematics with our forces. So this lab will help us do that. So what we have here is called a modified Atwood machine. A true Atwood machine would just be a pulley with mass on both sides of it. But since we have a surface that kind of takes away part of the two mass aspect, we just have a modified Atwood machine. So notice that I have a hanging mass. This is where obviously I'm going to put the mass on. It is going to be attached to the string on this side where our frictionless pulley is located. And then we have our frictionless track as well as our frictionless trolley. And the last part of this is that our string is actually frictionless as well. It has a polymer coating that makes it super slick. So we've really reduced friction for the entire system. Now, what I would like you to take notice of also is that we have mass on top of the trolley. I actually do have mass already put onto my hook. So the hook in the bottom is worth 50 grams, and then I have another 10 grams on top of it that I'm going to place on the end. Now, typically this is a point where I would say, okay, you're looking at about 5 to 6 observations that you're trying to make. And there are 2 things that I'd like you to focus on. The first thing that you need to focus on, obviously, is the motion. First of all, what type of motion do we have? And then why do we have that motion? So not only looking at the kinematics, but the dynamics as well. The second thing that you need to look out for is, what did I keep constant? Because we're going to see, especially in this lab, if you don't have your constants in place, one, you're going to be changing way too many variables, so you're not going to know what actually had an effect, but you're also going to get really funky data if you don't have your constants in play. So I'm going to go ahead and start out just with my 10 grams on top of my 50 and watch the trolley's motion. Okay, so 2 things that I'd like you to notice after those 2 trials. 1, I pulled it back to the same starting point each time, and then I'm also stopping the hanging mass the moment before it hits the ground. Because what we find when it actually hits the ground is, well, what type of motion does the hanging mass have? Well, if it hits the ground, it doesn't have any motion. So now I've gone from having motion to no motion, so I need to just focus on when it actually does have its motion, because once it hits and it stops, that's something totally different. So we can't have our time continuing, we can't have our trolley continuing, we have to only be focusing on one motion, so I am starting and stopping it at the same points. Here's my 10. And you will have some of your masses come off. So that will be one thing that you will have to problem solve through, is how can you make sure that your masses actually stay on the trolley? Another 20. this will be my last trial that I do. And you can actually screw off the bottom, leaving me with just the hook. Evidently, I was stuck. There we go. And this will be the last trial. So now I'm going to stop this video because what I need to do is bring you over to the whiteboard and see the observations, measurements, and essential question, and really talk about some of those things that I had held constant. All right, stay tuned for video number 2.